In this video, we'll be doing what we did before in the previous video with the EDLC, but this time we're going to be having a separator. And this separator is going to have a porosity of 75%. So in this video, we're going to be simulating a double layer capacitor, but this time we're going to be adding a separator into the mix. So we're going to be recycling a lot of what we did in the previous video with the device file and the jobs file, and we're going to be using it in here. There are going to be some edits in the job file, but I'll get into that later once we get there. So as to what we did previously, we want to make sure that we have the anode and electrode set to the double layering model. And the only thing that we're going to be doing new on the device file is that we're going to be making this to be a material with two phases, the electrolyte and binder. So we select our electrolyte, which is going to be LiPo6, and we select our solid matrix, which is going to be an insulator. Now, so what the solid matrix is that it's just the structure of the separator. So as to what the material is, isn't too important at the moment. So we're also gonna do a 50-50 split on the electrolyte and the solid matrix. So this is going to be set to 0.5. We also need to make sure that our initial concentrations are set in place. So I'm going to do 1000 for this. And then we also want to make sure that we're using the Brueggemann model for the affected properties. And we're going to leave these as default. So as to what we are going to be changing in the actual job file is that we're going to be changing the I cathode current to be negative 10 microamps. And another thing that we're going to be changing is that we're going to be changing the sweep parameters to be from 0.01 seconds to be 1 second. And so once we do that, and those are all the things that we're going to be changing in the actual job file. So as it is, it should be the same as to what we've done previously. Make sure to set this to be 0 so that the simulation can run faster. And then also need to save the device file so that it'll rebuild the circuit on the job file. And then we run this. So this is the concentration of the Li plus and PF6 minus. And this is the electrolyte potential. Here's the cell voltage. And here's the EIS. And as to shown previously before, it may look weird right now, but all you really need to do is just scroll out and it'll look proper as to how a capacitor should look. Now, one thing I want to note is that there was another thing that I didn't show as to what we changed, and that was the grid. So before, all of this was by default 100 nodes, but in this case I had to change this to be 1000 nodes, and there's a reason as to why. I'll just need to save this, close, I'll rebuild the circuit, and then close all of these. And the nodes didn't really make a difference in the plots for the cell voltage, the electrolyte potential, and the concentration. But I will show you what happened when the nodes were too small, and it only affected the EIS. As you can see, that there's this little huge error that pops up, and that's a result of aliasing. And this reason as to why I had the number of nodes be set to be 1000 instead of 100 is because in the calculations for the EIS, there just wasn't enough features for it to do a proper calculation. So at some point in here, when it was solving the equations, it was dividing by some really low number, close to 0, as you can see from the scale. And as a result, the aliasing popped up and created this huge error. And it doesn't show up unless you use a larger amount of nodes, which in this case I use 1000. So there's a trade-off in doing this, in that and it's mostly just in speed versus accuracy.